The Johnstone Supply Company Cafferty Group, with offices in Nebraska, Iowa, Kansas, and Colorado, presents Goodman Side Discharge Installation and Commissioning Technical Training Module, TRV 8, Part 2. Here are some pre-installation recommendations. Always refer to the installation manual for equipment clearances. Improper outdoor unit placement can affect the operation of the equipment, such as sound, unit vibration, defrost, air short cycling, and even the wind can cause a reduced capacity and efficiency of the unit. If you're going to stack units vertically on the wall, make sure you limit it to no more than 2 units with a minimum of 20 inches of vertical clearance between them. When mounting an outdoor unit on the wall, roof, or deck, please consider vibration transmission, which could cause noise. If mounting a unit on the wall or the roof, make sure the structure can support the weight of the unit, and you follow proper steps to keep a weather-tight integrity of the roof or wall. Since inverter-driven equipment utilizes digital communications between its components, it is important to keep the communication circuit a safe distance from devices that can create electromagnetic fields or radio frequency, such as televisions, radios, stereo systems, solar control panels, whole house generators, cable modems, internet routers, that sort of thing. RF or EMF interference can cause erroneous operation of the system. Since this is a conventional heat pump, it is shipped with a bi-flow liquid line dryer. If during the installation of that dryer it would become chipped or burned, repaint the dryer or coat with a rust inhibitor to ensure the integrity of the refrigeration system. The recommended installation location for the filter dryer is before the expansion device in the indoor unit. When the system is installed in a location that has a possibility of operating in a low ambient temperature condition, be sure to follow the instructions in the installation manual. Install the outdoor unit so that the bottom of the frame is at least 20 inches higher than the expected snowfall. Also, consider wind exposure so that the inlet air side of the coil is always facing the wall, and then, when necessary, install a wind baffle on the discharge side of the outdoor unit. Never install the outdoor unit where the inlet side is exposed directly to the wind. When installing a unit in a cold climate location, it is highly recommended that you use a drain pan heater in areas where the outside temperature gets below 32 degrees Fahrenheit for 12 or more continuous hours to prevent damage to the outdoor coil. Do not use an outdoor drain pipe kit, and remove the rear inlet grill to prevent snow from accumulating on the rear fins. Unit installation. Here's a piping diagram of a large chassis heat pump. Refer to the service manual for the diagram for the unit you're actually installing. These piping diagrams show the locations of the thermistors so you can plot the data and identify what thermistor you're looking at when you are using the D-checker. This makes starting up and servicing the unit much easier and more accurate than attaching your own thermistors to read temperatures. When installing refrigerant piping, here are a few things to consider. Do not install dryers, oil traps, side glass, or any other components in the refrigeration lines unless you're instructed to do so in the installation manual. Never install a suction line dryer on a heat pump. Only use refrigerant-grade copper tubing for your line sets. Make sure you have good, straight, clean cuts on the copper line, only made with a tubing cutter. Make sure the copper is clean to avoid contamination. If you're reusing an existing line set, inspect it thoroughly. Remove any sections of copper fittings that show damage before installing the new unit. Damaged refrigeration lines and fittings can cause bad performance and damage the compressor. As for insulation on refrigerant lines, the gas line must always be insulated between the indoor and the outdoor unit. This prevents condensation from forming and dripping from the lines. If the line set passes through an area more than 50 feet long that would reach temperatures 30 degrees Fahrenheit or more above outside ambient temperature, then the liquid line should also be insulated. Install the insulation in a way that it will protect the tubing from damage and contamination. 3/8-inch wall insulation is recommended, but if you are in severe conditions, very hot or humid areas, then you may need to go to 1/2-inch insulation. Support the refrigerant piping with brackets that will hold the pipe firmly but still allow for expansion. Use metal or heavy nylon wire ties to securely anchor your line set. If the application is more than 80 feet of refrigerant lines, the tubing is prone to transmit noise or vibration to the structure because of pulsation in the line set. Make sure you use adequate vibration-absorbing hardware when you are mounting the line set to the structure. If you are reusing an existing line set, be sure to remove any existing oil that could be left in the line set in traps or low areas. Pay special attention to low areas of the line set where oil could collect. Drain the oil and do a nitrogen flush. If the new unit you are installing uses a different refrigerant than the one that was existing, you must flush the existing refrigerant lines with a professional flushing agent to remove any existing oil, debris, or refrigerant. Draining the legacy oil from the system and using a passive nitrogen flush is recommended. Maximum actual line length is 100 feet. The maximum equivalent line length, including fittings, is 125 feet. Maximum vertical separation if the outdoor unit is above the indoor unit is 100 feet. If the outdoor unit is situated lower than the indoor unit, the maximum total line length is 100 feet. The maximum equivalent line length, including fittings, is 125 feet. The maximum vertical separation is 90 feet. Also note that the suction line must have an inverted trap with a loop that extends higher than the top of the indoor coil. Preparing for brazing, make sure you remove the Schrader core so that they won't melt from the heat of brazing the line set. Always use a brazing alloy with a minimum of 2% silver content. 15% is recommended. Never use flux. Wrap all the valves with a wet rag or heat gel to prevent damage to the valve. If the biflow dryer paint is scratched or burned, corrosion may occur, rusting and causing a loss of integrity of the refrigeration system. You must use dry nitrogen while brazing to prevent oxidation from forming inside the pipe. Leave the opposite end of the tubing open so that the nitrogen can exit. Purge the line set for 15 to 30 seconds at about 20 psi. Then allow nitrogen to flow at 1.5 to 3 psi while brazing. Then cool the brazed joints with water or a wet cloth to prevent overheating the service valve and the filter dryer. Here are a few things to consider when doing a nitrogen pressure test. Nitrogen pressure is subject to fluctuation based on ambient temperatures, not as much as air, but still subject to fluctuation. The formula below will help determine system pressure drop caused by low ambient temperatures or a change in temperature. Use this formula to compensate for temperature changes from one day to the next when performing a pressure test. This applies when nitrogen pressure is over 300 psi. When charging the system with nitrogen for a pressure test, do it in increments to ensure the integrity of your braze connections. Charge to 150 psi, allow that to remain for approximately 3 minutes. Then, increase that charge to 325 psi, allow that to sit for approximately 5 minutes. Then charge the system to 450 psi, or whatever you choose as a high pressure test. Overpressurizing the system could cause dry nitrogen to leak past the service valve into the refrigerant circuit of the outdoor unit, contaminating the refrigerant. Once you are certain that your system is leak-free, perform a triple evacuation. Performing a triple evacuation is the only way to ensure that that line set is dry. Evacuate the system at 4,000 microns and allow it to stay there for 15 minutes. Break that vacuum with dry nitrogen and pressurize it to 2 to 3 psi and allow that to stand for about 20 minutes. Evacuate the second time to 1500 microns and hold that for 20 minutes. Break that vacuum with nitrogen, pressurizing to 1.5 to 3 psi and holding for 20 minutes. Your third and final evacuation should be at least 500 microns or below for 60 minutes. Make sure you do a 60-minute rise test to ensure that that line set is sealed and dry. Once the evacuation is complete, you can use that final vacuum to pull in the additional refrigerant charge if it's needed. The system is charged for 15 feet of line. Consult your installation manual for calculation of additional charge for line sets over 15 feet. The tools needed to perform a triple evacuation are as follows. Vacuum-rated hoses. The larger the diameter of the hose, the shorter the evacuation time. The red, yellow, and blue hoses that come with a manifold gauge set are typically not vacuum-rated. When possible, try to avoid using a manifold set for an evacuation. A properly maintained vacuum pump is essential in evacuating a refrigerant system. You should have a 2-stage pump with a minimum capacity of 2 CFM. Please beware of using large pumps. If you evacuate too quickly, ice can form inside the pipe, causing false readings on your vacuum gauge. Check the valve and the oil level in your vacuum pump. Vacuum pump oil must be changed frequently, not only when the vacuum pump tips over in the back of the truck. A micron vacuum gauge is an absolute necessity for the entire evacuation process. Without a vacuum gauge, there's no way of knowing when you have a proper vacuum. Manifold gauge sets will not show you that information. And lastly, use a vacuum-rated Schrader core removal tool. Removing the core increases the diameter of the valve so it reduces the time of the evacuation. There are reduced leak points compared to using a manifold gauge set. So now, for charging the system, how do you calculate the additional refrigerant charge? The outdoor units are shipped from the factory with a predetermined amount of refrigerant. The factory has no way of knowing what the finished line set length will be on the job, so it's up to the installer to measure the length and diameter of the new or existing line set they will be using. Charging tables are provided in the installation manual for the outdoor unit. Only the 1.5-ton unit uses a 1/4-inch liquid line. All the other sizes use a 3/8 liquid line. The total refrigerant charge is equal to the factory charge, which is listed on the data tag of the unit, and the additional charge, which you will calculate by line length and line diameter, from the installation manual. After the final charge is calculated and installed, you should not add more than 1/2 pound or 8 ounces of refrigerant in order to achieve your target subcooling. If you're having trouble getting that target subcooling, we recommend that you add 1 ounce of refrigerant at a time and let the system stabilize for 10 minutes before adding more to prevent overcharge. Here are some examples of the charge tables in the installation manual. Notice that each one shows the line set diameter, and there's an A column and a C column. The A column is the total charge. C column is the additional charge that you would add. So in this case, if we had a 1/4 and 5/8 line set, and the line set was 60 feet long, the total charge is 80 ounces. The additional charge that we would have to add is 4 ounces. Make certain that you have the correct charge table for the unit you're working on. Here are a couple other examples of different size unit charge tables. Inverter-driven equipment carries different voltages on the control board than does standard equipment. Inverter smoothing capacitors could hold up to 370 volts DC. Therefore, voltage separation is required per UL 1995 standard. The green section that you see here is a high voltage. High voltage could be AC or DC. Main power, compressor and fan power, power to the subboards, power conditioners, anything that would be dangerous to the technician. The red section that you see here is low voltage, such as communication cables, all your sensors such as thermistors and pressure switches. and even thermostat connections. For technician safety, these things must be separated on the control boards. So before touching the inverter board, make sure that you power the unit down, give it a few minutes for the capacitors to drain, and then measure voltage between terminals C positive and C negative and ensure that it's less than 50 volts DC. Here is an example of a main control board and the service control board in a 1.5 to 3 ton outdoor unit. On the 1.5 to 3 ton units, the main control board will have a heat sink attached to the back side of it, which are aluminum fins that go out into the airflow to cool the inverter section while the system is running. Across the bottom of the main PC board, you'll see the locations for the pressure sensors, thermistors, and other monitoring devices. You'll also notice the location of the condenser fan connector, which is DC voltage. Also notice the location of the choke coils, which are part of the noise filter. Here are the smoothing capacitors, which are part of the inverter section. There are also the U, V, and W terminal access points for the compressor. Please keep in mind that the voltage between U and V, V and W, W and U should be equal and balanced. It really doesn't matter what that voltage is, as long as it's the same between all terminals. Also, it is important to know that that is a simulated AC voltage made of DC. You will set your meter to read AC. Be extra careful when you're reading the compressor voltage. Even though it's reading as AC on your meter, it's made up of DC, which means DC could arc together between terminals when testing, which would damage the circuit board and quite possibly your meter. On the right side, you'll notice a layout of the service PC board, which contains the port for your D checker, shared data port, display, dip switches, data connections, etc. Here is an example of a 3.5 to 5 ton circuit board. You'll see that the connections are all present on this board as well. However, the main difference is there is no heat sink on the back side of the board. Instead, you'll see a DX loop run across the board and attached to the inverter circuit. It is highly recommended that a voltage monitor and surge protection device is used to protect the equipment from voltage fluctuations or electrical power surges. Here is a list of minimum circuit ampacity and maximum overcurrent protection devices recommended for each size unit. Always use insulated power wires with copper conductors. Size power wires in accordance with your local codes. Pertinent unit electrical information is listed on the data tag on the unit. Wires should be sized to limit the voltage drop to a 2% maximum from the main breaker. Do not install a disconnect switch on the outdoor unit. Although local code may require a disconnect switch be located near the outdoor unit. 3.5 to 5 ton outdoor units have an optional knockout to route high voltage wiring through. Route power supply and ground wires through the high voltage port and terminate in accordance with the wiring diagram. Connect 208/230 single phase field wiring to the terminal block located in the electrical panel. Do not install a thermostat where it could be affected by drafts or dead spots behind doors and in corners, hot or cold air from ducts or ceiling fans, radiant heat from the sun or appliances, concealed pipes and chimneys in the wall, or unconditioned areas such as outside walls. Mount the thermostat so it can be leveled, approximately 5 foot from the floor and on an interior wall using the included screws. We're using the CoolCloud HVAC app. The GTST thermostat must be used when you're setting up communications in this system. Note that the system is not comfort bridge controlled. If it's wired to a comfort bridge furnace, the installer must check for critical OTA updates through the CoolCloud app before commissioning the system. Do not energize the controller until you have verified that the critical OTA update is complete. The CoolCloud app is available in Apple or Android versions and can be found in the Apple Store or the Google Play Store. When setting up a CoolCloud app, there are 3 permissions required by this application: access to photos, Bluetooth scanning, and device location. Login and registration screens. Log in where you have a strong cell signal or, if possible, on a Wi-Fi network. You'll need to create an account to get started. If you are a new user, you'll have to provide some registration information to start your account. Once you set up your account username, it cannot be edited. If you want to make changes to your account information, you need to create a new account. Move close to the equipment, open the app, and the indoor equipment should appear on the device screen. Random Bluetooth equipment within range may just show up on the app, but you can simply ignore it. If the equipment you're searching for doesn't appear on the screen, just hit refresh in the upper right-hand corner. A unit may not show up if it's out of Bluetooth range, if another user is connected to the same Bluetooth device, or if the unit's not powered up. Tap the desired equipment to begin the connection. Pressing Logout takes you back to the previous login screen. Once you're paired to the equipment, available software updates will be displayed. Mandatory updates are required before moving forward. Optional updates can be downloaded or you can skip them. The screen will show you whether it is a required update or an optional update. Pair by device allows the user to enter the 3-digit code that's displayed on the device circuit board. The device cannot be paired using the smart thermostat. If you would like to pair to the unit by using the circuit board code, if you can see the code on the unit, just enter that number into the code entry screen as shown on the right. The low voltage wiring detail when you're paired with an air handler. Minimum of 18 gauge wire, but since this is for DC communication, beware of using too large a wire. 16 gauge maximum should be fine. Maximum wire distance between the communicating thermostats and the indoor units is 125 feet. Maximum distance between the indoor units and the outdoor units is 250 feet. 4 wires are required between the indoor unit and the coil PC board to the thermostat. 2 wires are required from the indoor unit to the outdoor unit. The low voltage wiring detail when you're paired with a gas furnace, thermostat, and a cased coil. From the furnace to the cased coil to the thermostat, wiring should be a maximum of 125 feet. You will see that you do have an R and a C wire between the furnace, coil, and thermostat to carry power. Wiring between the indoor and the outdoor unit carries communication only and is limited to a maximum of 250 feet. Communication is established from the outdoor unit. Communication circuit should be a daisy chain between the outdoor unit, indoor unit, coil, and the thermostat. When you're dealing with multiple conductors, twist the wires together before you insert them into the terminal block. Avoid using different size wires and different types. Also avoid inserting more than 2 wires into the same terminal connection. On the communication daisy chain, you can use a single wire connected to the terminal board and a good quality wire nut off the circuit board to complete the daisy chain. Remember, good wiring practices ensures low resistance connections for a cleaner communication circuit. If you are using multi-conductor solid core thermostat wire, do not wrap the extra conductors around the jacket like you would with the spare wires on a conventional system. Ground only one end of the wire, and the preferred grounding spot for that would be the indoor unit. Another option to improve communication reliability is to twist 2 of the extra conductors together. Place 2 of them under data terminal 1 and 2 of them under data terminal 2. 18 gauge 2-conductor stranded shielded cable may be a better choice for a communication circuit. Here's an example of incorrect communication wiring. Remember, communication is a daisy chain. Outdoor unit to the furnace, to the coil, to the thermostat. Do not create a landing point for multiple connections. If low voltage wire requirements are not met, check the wiring connections for cross wires, loose wires, broken wires, bent wires, etc. Replace the communication wiring terminals 1 and 2 with 18 gauge 2-conductor stranded shielded wire is recommended. Move dip switch 1 switches on the outdoor unit circuit board to the opposite position. The UT3000 zone control will control up to 3 zones from a single board and up to 5 zones from twinned boards using a 24-volt open and close motorized damper system. EWC zoning complies with the Manual ZR, ANSI or ACA 11 Manual ZR 2018. When paired with the EWC, you must set lockout temperatures from the UT3000 zone control board menus. You must set the zone weights from the UT3000 zone control. Default settings are as follows. The 3-zone, 70, 15, and 15%. 2-zone is 60, 40%. Here's an example of the zone control system layout using communicating thermostats. When communicating thermostats are used on all zones, the zone panel will interpret the communicating thermostat demand and stage or modulate the HVAC system to meet the demands of each zone. When using the UT3000 zone control and adding the new Distributed Air Pressure Controller or DAPC module, the DAPC module can monitor the system static pressure and send open and close commands to the zone panel to modulate damper positions to regulate the static pressure. When the system static pressure gets too high, the DAPC will modulate the closed dampers to the open position to control the static pressure. The DAPC's default static pressure set point is 0.5 inches of water column. Static pressure set points can be adjusted, however, from the DAPC module as low as 0.15 inches to 1.5 inches. You can customize and allow the DAPC to discover the actual non-zoned static pressure of your system and adopt that value as a static pressure set point. Here is a list and locations of the inverter PC board components on a 3.5 to 5 ton. D-checker port, shared data port, dip switches, thermistor bank, outdoor fan motor, the 7-segment display and the push buttons, data connections, compressor terminals, reversing valve solenoid, outdoor EEV, low pressure sensor, high pressure sensor. System commissioning. Cloud commissioning over Wi-Fi. If you haven't already done so, download the Goodman Installer app from your Apple or Google Play app store. You do not need to create an account to log in. The default user ID and password, which is case sensitive. The user is Goodman, uppercase G. The password is dealer, uppercase D. System profile enables the technician to modify the settings from the app and upload those settings to the thermostat. Create a job based on the location. Every job needs the location details. Click the plus sign to add location details and continue. The user can use their GPS location to automatically fill in the address if you so desire. Add the thermostat to the job and configure for zoning if applicable. Add thermostat by tapping on the plus sign in the top right-hand corner, then scanning the QR code or entering the DKNS number manually. The QR or 2D barcode can be found on the subbase. The DKNS number is found by navigating through the thermostat menus. Zone board configuration can be seen by sliding the toggle button to the right. If the thermostat is connected to a zone controller but not Zone 1, then the equipment information will not be available. Connect to the thermostat using AP or auto programming mode. When you select any task, internet connection will be verified before the user can continue the setup. If the Wi-Fi icon is gray, the system is not connected to the Wi-Fi. To connect to Wi-Fi, first click on Apply System Profile. On the thermostat, press and hold the fan button for 5 seconds. Release the fan button and press the down button to continue. It takes approximately 10 seconds to enter AP mode. AP mode must be active before tapping Discover Device. When connecting to the thermostat's access point, the mobile device must be within 2 feet of the thermostat. Once you're connected to the thermostat, following the cloud commissioning process, you can connect to a local Wi-Fi network and no longer need to be within 2 feet of the controller. It must be password protected. It will show a list of equipment once you are connected to the Wi-Fi. Verify equipment, then continue to view the thermostat profile options. Once you're connected to the Wi-Fi, the green icon with the check mark in it will be displayed. If the 24-hour access is expired, then you will not see that icon. You can select and/or modify any profile to send to the thermostat. Make the edits as needed, then tap Send to Thermostat. Modifying the profile does not affect the default profile. When you're running a system test, you will be prompted to calculate the charge before running the test. Measure the total line length, then select liquid and suction line diameter before calculating the required trim charge. Enter the actual charge you weighed in. Verify that the service valves are open. Tap Run Test. Then you can leave the screen while the test is running and return as you need to. System test is required. If the test is not completed, an error code 11 will be generated, but error code 11 will clear once the test is complete. When you run the system charge verification, the recommended charge needs to be added to meet the required charge that's displayed. Measure subcooling and verify proper specifications are met using the charging chart in the IOM. Once a system is stabilized and is running at full speed, the calculated subcool will be displayed. Give it up to a 5-minute delay between gauge readings and the app verification. Stopping the verification will generate a report. After all the steps are complete, you can share a commissioning report before completing the job. Apply system profile without Wi-Fi. Download the Goodman Installer app from your respective app store. You do not need to create an account to log in. The default user ID and password, which are case sensitive, are user Goodman with an uppercase G, password dealer with an uppercase D. System profiles make it so the technician can modify settings from the app and then upload those settings to the thermostat. On the thermostat, press and hold the fan button for 5 seconds. Release the fan button and press the down button to continue. It takes approximately 10 seconds to enter AP mode. AP mode must be active before tapping Discover Device, and when you are connecting to the thermostat's access point, the mobile device must be within 2 feet of the thermostat. A list of detected equipment will be populated once the equipment settings are detected. This may take several minutes. Verify equipment, then continue to view the thermostat profile options. You can select and modify any profile to send to the thermostat. Make the necessary edits, then tap Send to Thermostat. Without being connected to a network, you must be within 2 feet of the thermostat to send the data. Modifying the profile does not affect the saved profile. Running a system test without Wi-Fi. On the thermostat, press and hold the mode and fan buttons at the same time for 5 seconds to enter setup options. Scroll down to step 20 by pressing the mode button. Holding the fan button for approximately 2 seconds will turn system test on. System test cannot be stopped once it's started. This test should take about 15 minutes to complete. The display will cycle through the message, System Test Running while testing. When the system test is complete, press the mode button to return to the main menu. Running charge verification without Wi-Fi. On the thermostat, make sure the system is in cooling mode and drop the set point to the lowest cooling temperature, which is approximately 50 degrees Fahrenheit, to run maximum cooling. The system must reach maximum speed to charge the system and measure subcool using gauges and a temperature clamp. Weigh in any additional charge needed to meet the requirements of the corresponding charging chart that can be found in the outdoor unit IOM. Charge verification can be initiated by navigating through the screens on the display of the outdoor unit. Instructions for this process can also be found in the outdoor unit IOM. To verify the refrigerant charge, if the ambient temperature is between 65 degrees Fahrenheit and 105 degrees Fahrenheit, and the unit is operating at 100% capacity, add refrigerant to match the chart that's shown on the right, which can be found in the outdoor unit IOM. If the outdoor ambient temperature is less than 65 or more than 105 degrees Fahrenheit, weigh the charge in. The subcooling value is only valid while the unit is operating at 100% compressor speed. Subcooling values are shown on the display board of the outdoor unit only during charge mode. If you would need to modify the profile, you can select and/or modify any profile to send to the thermostat. Profile settings are displayed in a scrollable list. Make edits as needed, then tap Send to Thermostat. Again, modifying the profile does not affect the saved profile. Let's talk about cool settings. For cool airflow trim, the airflow may be adjusted from -15% to +30%. Adjusting your intermediate and low airflow trim settings lower can improve dehumidification. Before adjusting your airflow trim settings, verify duct system and airflow requirements. Refer to the I/O manual for restricted airflow combinations. The system offers several custom on and off ramping profiles for the cooling mode. These profiles can be used to enhance cooling performance and increase comfort level. For cooling airflow profiles, refer to the installation manual. There are 4 cooling airflow profiles available. All residential inverter systems are factory set at Profile D. All of these profiles can be found in the installation manual. Dehumidification settings. The thermostat reads the indoor humidity level. Target humidity set point is adjusted once setup has been completed. The thermostat controls the humidity level of the conditioned space using the cooling system. Dehumidification is engaged whenever a cooling demand is present and humidity levels are above the target level. Circulating fan output is reduced, system runtime is increased. Dehumidification demand is controlled based on the humidity differential between set point and the detected humidity. If the room temperature is 2 degrees Fahrenheit higher than the set temperature, dehumidification demand will be set to prioritize to room temperature control. After you've set your dehumidification settings, the dehumidification performance can be improved by changing the dehumidification profile in the smart thermostat to A, B, or C. Settings for these profiles can be found in the IOM. The settings can be changed from the dehumidification setting menu at any time when it's required. The minimum compressor speed will be locked depending on the selected profile. The operating range limitation will be unlocked when the humidity reaches the set value. There must be a call for cooling and a demand for dehumidification. For heating airflow settings, the user can change the heating airflow trim at high, intermediate, or low compressor speed. Airflow may be adjusted from -15% to +15%. Refer to the IOM for restricted airflow combinations. Please note, lower heating speeds will reduce electrical consumption, lower operating sound levels for the blower, and increase the outlet temperature of the air delivered to the space. So let's talk about defrost. Defrost heat. You can select the outdoor temperature for backup heat to activate during defrost, at or below 30 degrees Fahrenheit to 65 degrees Fahrenheit, or you can turn it on or off. So you can opt to use backup heat during defrost or not use backup heat during defrost. Defrost intervals are adjustable, 30, 60, 90, or 120 minutes between defrost cycles, selected from the thermostat menu. If the defrost sensor drops below freezing temp during the selected interval, the outdoor unit circuit board initiates the defrost cycle. The outdoor fan motor and compressor will de-energize. The reversing valve switches from heating to cooling. The outdoor unit circuit board communicates to energize backup heat if that's enabled. The coil and defrost sensor temperatures are monitored every 5 seconds. When the coil temperature reaches 54 degrees and the defrost sensor temperature is greater than 43 for 30 seconds, defrost operation will end. Here's how intelligent defrost works. The best scenario is to keep the defrost cycle as short as possible. If it takes longer than 5 minutes to reach the target coil temperature, then the interval time that you selected will be shortened for entering the next defrost mode. If it takes less than 5 minutes during the defrost mode to reach target coil temperature, then it will lengthen the interval before entering the next defrost mode. As for the heat pump settings, auxiliary heat, whether it is electric heat strips or your backup gas heat, can be energized above lockout temperature if the following conditions are met. The space temperature is approximately 4 degrees Fahrenheit lower than the set point. There is a demand between 110% and 200% of the system. For dual fuel operation, you can select to prioritize efficiency or comfort. Selecting to prioritize efficiency, the selected balance point will be a hard lockout. Heat pump operation above the balance point, or furnace operation below the balance point. Selecting prioritize comfort will cause the system to run with the logic listed above, such as energizing backup heat at 4 degrees below set point, or for a high demand on the system. The GTST Smart Thermostat is compatible with multiple accessories such as auxiliary heat sources, humidifier, dehumidifier, UV light, electronic air filter, HEPA filter, EWC zone board, or the D24-volt gateway. You can install an auxiliary heat source, humidifier, or dehumidifier by using the auxiliary and auxiliary C terminals. However, it is recommended that you use an isolation relay between the auxiliary device and the thermostat, such as a single-pole, single-throw relay that's normally open. For auxiliary heat source, enabling the equipment by tapping the toggle button will allow you to configure an auxiliary heat source. This is not for setting up a heater kit for electric backup heat. This is used for setting up a backup heat source such as a boiler, a duct heater, or a boiler with a hot water coil. Auxiliary heat source is the only control option for a cooling-only outdoor unit. Secondary heat setting control will allow you to adjust the settings such as lockout and secondary heat activation temperature. Emergency heat mode will appear as a system mode when connected to a heat pump and can be used to directly turn on the auxiliary heat source if it's enabled. T-on and T-off give you an alternative control method to having the main AC or heat pump control the auxiliary heat source using PI control algorithm. T-on and T-off is the only control option for auxiliary heat with cooling-only units. If the indoor unit is a gas furnace or an air handler with a heat strip, these heat sources can be controlled around the heat set point by the demand-based pulse input algorithm. When T-on, T-off is selected, the auxiliary heat source will be controlled independently using these settings. When a heat pump is your primary heat source, heat pump lockout temperatures are adjustable from minus 20 degrees Fahrenheit to 65 degrees Fahrenheit in 5-degree increments. Default is 15 degrees Fahrenheit. Auxiliary heat lockout temperatures are adjustable from minus 10 degrees to 75 degrees Fahrenheit in 5-degree increments. Default is 50. Auxiliary heat demand. T-on differential is adjustable from minus 7 to minus 3 degrees Fahrenheit in 1-degree increments. Default is minus 3. T-off differential is adjustable from minus 4 to 1 degree Fahrenheit in 1 degree Fahrenheit increments. Default is 1 degree. When auxiliary heat is your primary heat source, the heat pump lockout temperatures are adjustable from minus 20 to 65 degrees Fahrenheit in 5-degree increments. Default is 15 degrees. Set point differential can be set at minus 9, minus 7, minus 4, and minus 2 degrees Fahrenheit. Default is minus 2. Heat pump demand T-on differential can be set at minus 1 or minus 2 degrees Fahrenheit. default is -1. T-off differential is fixed at 1 degree Fahrenheit. When you're setting up the control for humidifiers, on with heat will activate the humidifier every time there's a call for heat. On with heat and humidity will activate the humidifier every time there's a call for heat and humidity. On with humidity will activate the humidifier anytime there's a call for humidity. Approximately 3 minutes is the delay time. On with humidity, the call for humidity will activate at 3% below set point and will deactivate at set point. Humidity control using the AHVE air handler. For the setup for humidification functionality, the accessory terminals have 3 operational modes. Number 1, on, the humidifier will be enabled during a call for heat. That means that during any call for heat, the accessory relay will close if there is an active call for humidification from the thermostat. Number 2, off. Humidifier remains off and the relay is open. Number 3, independent. The humidifier will cycle with any active call for humidification from the thermostat that's independent from a call for heat. The relay will open during cooling operation. This allows the user to select one of 4 fan speeds, 25, 50, 75, or 100%. The fan speed is used when the system is in an idle state and there is no call for heat, but there is a call for humidification made by the thermostat. When using a heater kit, it is important to set the capacity of the electric heater at 2 locations, the thermostat and the dip switch bank number 3, dip switch settings 9, 10, 11, and 12 of the air handler circuit board. Set the dip switches according to the chart on the right side of this screen, also found in your IOM. The auxiliary alarm for the AHVE air handler. The control is equipped with 2 auxiliary alarm terminals. Alarm terminals TB4 and TB5 are typically used in series with a condensate switch, but can also be used with a compatible CO2 sensor or fire alarm. The auxiliary switch is normally closed. Alarm occurs when the switch is opened. Note that errors will be kept in the equipment's fault memory. For deadband and overcool, the overcool value is overlaid on the deadband. Increase the range to maintain the minimum cool-heat differential of at least 2 degrees. Let's talk about the boost mode. The boost mode allows the compressor to operate at a higher speed than the factory maximum. Maximum RPS value is hard-coded into the software and cannot be changed. Cooling boost mode outdoor activation temperature can be adjusted in the boost mode menu. Boost mode will operate after the ambient temperature increases higher than the selected activation temperature and the compressor has achieved its maximum revolutions per second. Heating boost mode is enabled and disabled by selecting on or off. On the GTST, you may select the maximum revolutions per second offset. This allows you to adjust plus 10% RPS from the factory maximum RPS. Outdoor unit error history. Screen 0, the current fault will be displayed on the screen. Screen 1, fault history, which will store the last 6 faults. Hold the recall button for 5 seconds. The first screen that is displayed is 1.00. The next thing that appears will be the first fault. Press recall again for 1 second and the first fault will appear. Press recall again and the second stored fault will appear, and so on. It is important to check duct static pressure. Refer to the rating plate for the maximum external static pressure. Incorrect static pressure can cause excessive temperature rise, motor stress, duct stress, reduced performance, unwanted condensation by blowing water off of the coil, etc. For checking duct static pressure, positive pressure is measured on a furnace at the supply outlet and must be read between the furnace and the cooling coil. On an air handler, an MBVC should be measured at the supply outlet. The negative pressure on a furnace should be measured at the return air plenum and must be read between the furnace and the filter. On an air handler, at the return air plenum must be read between the air handler and the filter. On the MBVC, negative pressure should be measured between the modular blower and the cased coil. Please be very careful when you're drilling holes in the cased coil not to damage the coil. When you're taking static pressure readings for a gas furnace with a coil, the design static of most furnaces is approximately 0.5 inches of water column. Use a manometer or magnehelic to measure the static pressure for the furnace only. Supply side should be measured between the heat exchanger and the evaporator coil. Return side should be measured between the blower wheel and the filter. Getting static pressure readings on a single-piece air handler, the evaporator coil has been installed at the factory and is already considered in the static pressure calculation. Use a manometer to measure the static pressure of the air handler only. Measure the static pressure of the supply duct at the outlet of the main air handler in the supply plenum. Measure the static pressure of the return duct at the inlet of the air handler, downstream of the filter. When you're measuring the static pressure of a two-piece air handler, the evaporator coil is not part of the air handler, so it must not be considered in calculating static pressure. Use a manometer to measure the static pressure of the air handler's blower assembly only. For positive pressure, measure the static pressure of the supply duct at the outlet of the unit in the supply plenum. For negative pressure, measure the static pressure between the outlet of the evaporator coil and the inlet of the air handler. Some of the problems caused from high static pressure can include reduced airflow, limit or pressure switch tripping, and long-term will tend to shorten the life of a compressor, heat exchanger, motors, and other components. You can test the pressure drop across individual components using a manometer or a magnehelic. For instance, if you have 0.4 inches of water column static pressure across the evaporator coil, the coil is dirty. If you have 0.3 inches of water column static pressure across the air filter, then the air filter is dirty. You can click on the QR codes to get the checklist for the Goodman side discharge system or the test data sheet for the side discharge system. If you have any questions or need more information, please contact your local Johnstone Supply Company Cafferty Group office. Please continue this training by going to part 3 of this video.